Hello, Honors Geometry, and here we are back again for another video in Unit 1, the Geometry Basics. Today, if we're looking at our topic, we're covering angles. So far in our time together, we started out talking about points, then we spent some time talking about different lines. We had the lines, our regular lines that have the arrows on both sides that go on forever. Then we spent last lesson talking about segments. Today we are going to be going to the other type of lines, which are rays. So getting right into this lesson on angles. The first question that we really get into is, how is an angle formed? Well, an angle is formed by two rays touching at the endpoints. Now, when we talk about touching, we can also talk about it could be mentioned that they are sharing. So remember, a ray, first off, if I draw a symbol of it below, has an endpoint on one side, the arrow on the other. Okay, what is going to happen is that two rays are going to touch or share this common endpoint to form an angle. So if we look at it, I'm going to draw one ray down here at the bottom. My endpoint, my side with the arrow. Off of that endpoint, I'm going to just go in another direction and draw that same ray. They are sharing this common endpoint. Now, what is nice about this is this endpoint that they share, this is known as the vertex. Okay, and then the other thing that is part of angles are the rays. The rays are known as the sides of an angle. So each angle has two sides and one vertex. Okay, so now, since we know what angles look like, the main thing that we have focused on when we are talking about points, lines, line segments, rays, was how do we name those? Because what we're going to get into is when we start to introduce shapes in different units, we're going to see it written in the form of capital letters, and we have to know that that means points. Or we're going to see something with a line segment symbol above, and we have to know that's a line segment. So now it comes down to, how do you name an angle? So there are three ways that we can name an angle. One way is to name it by its vertex. So it will look something like, you can do the word angle, or you could have a symbol of the angle. Then with the capital letter, this is going to be the vertex point. Okay, it's not always going to be an A, it's going to be whatever that vertex point is. Okay, there will be a letter here at the vertex. That's what gets substituted in there. Okay, a second way that we name it is with a letter or number inside. So sometimes inside this, there will be letters or numbers, and we can name it by that. And again, it's going to look something like angle, or this angle symbol with a letter or a number after it. Okay, and the third way, which is a common way, is to name it with 3 points. The big thing is the vertex is in the middle. So what's going to happen is you're going to start at one of your sides. There's going to be a point on it. Use that, go to the vertex, go to the other side to get another point. It doesn't matter which side you start and end with. Okay? The only thing that matters when you name it by the 3 points is that the vertex has to be in the middle or the center. Okay, so if we look here at an example. Okay, I'm going to draw one picture here and we'll name them all three ways. Okay, so if we name it starting here with way 1, which is to name it by the vertex. Okay, a lot of times you rarely see them written out angle this way. They like to use the symbolic form of angle. The more you learn in mathematics, the more you learn mathematicians like to be lazy. The easy way out is the way to go. So that's why they use the angle symbol. And then if I'm naming it from the vertex, the point in the middle that they share is B. So I can name this angle B. Okay, if I go to the second way, use it with a letter or a number inside. Inside my angle, I see a 2. So I can also name this angle 2. Okay, and the third way, start with a point on either of the sides. So if I start here with A, angle A, then go to the vertex, which is B, C. Now, you could always do it C, B, A as well. Your first and your last point do not matter. All that matters is that middle point has to be B because that is the vertex. Okay, it is that end point that they share in common on both of the rays. So now that we have seen an angle, we've talked about how to name an angle, let's talk about some special types of angles. One of the special types of angles is a right angle. Okay, these are angles that measure 90 degrees exactly. Now, what these are going to look like in our pictures, there's two ways you can see them. Okay, we can have our angle, we have this vertex down in the bottom left-hand corner. One way to see a right angle is to simply have 90 degrees written inside of it. Notice since this has a degree marking, this is different than the 2 up here above. When naming an angle based off of a number inside, if it does not have this degree symbol, it is a number for the angle. Okay, the other way that we see a right angle is they put a box. Okay, they put a square where the vertex is. This square equals 90 degrees. So instead of writing out 90 degrees, they can go the lazy man way and put a box in there that represents 90. Okay, another special type of angles is acute angles. These are angles that measure less than 90 degrees. Less is the key word. So you're going to have pictures that look smaller than these right angles. So I could simply have a drawing here. This angle is an acute angle because it looks less than a 90 degrees. 90 degree angles look like corners. Okay, this is like a corner. You have a wall, they meet at the corner. Okay, this does not look like a corner of a wall, it looks something smaller, making it acute. Okay, if we go on looking at more types of angles, we have our next one is what are obtuse angles? Okay, these are angles that measure less than 180 degrees, but more than 90 degrees. These really are angles from 91 to 179 in terms of degrees. Your obtuse has to be bigger than a right angle and less than 180 degrees. Okay, and if I give an example of this, it looks something bigger than a corner, because my corner would be somewhere like this, but it doesn't look anything bigger than 180. 180 is when we get down here, this next one, a straight angle. Okay, so if it's something between a corner and a straight angle, that makes it obtuse. Okay, and I've already somewhat answered this. What are straight angles? These are angles that measure 180 degrees. Okay, these ones are a little bit hard because you simply see it as looking like a straight line. But as long as they name 3 points on it and they have the angle, that makes it a straight angle. Okay, big thing is it's 180 degrees and it looks like a line. Okay, all of these straight angles look like lines. So now that we've looked at the different types, we've talked about the vertex naming, and let's look here at some examples. Okay, the big thing about these examples here on the angle one. Okay, these first ones not so much. When we get back here to the other examples, sometimes these problems are going to have more than one possible answer. If you see a different answer than what I see in the notes, you can always message me, check it to see if it is correct. You could write that as your question at the end, and I will make sure to answer if you are correct or not. So looking here at this first one, we're looking at this angle here to the right. First thing they want me to do is to name the vertex. First off, a vertex is a point, so we should be naming a vertex with a capital letter. Okay, the vertex is the point in the middle. The point in the middle is K, so I simply write a capital K there for the vertex. Okay, the next thing they want me to do is to name the sides. The sides are rays. Okay, first off, this vertex, this is the end points for both rays. So one of my rays starts at K and it goes off into the direction of L. I'm using that end point going off to the direction of the arrow, putting the symbol above. The other side goes from that same end point, just goes in the opposite direction, so it would be K and then J. Your sides will always start with the vertex, then a point in the direction of the arrow. Okay, then they go down to name 3 different ways to name the angle. One way to name it is with the vertex. Angle, my vertex was K. The other ways to name it are with 3 points. Starting with a point on one of the sides, let's say J, I go to my vertex, a point on the other side, so JKL. Notice, I started with one of the sides, went to the vertex, went to the other side. Then I can remember, always switch the first and the last letter, so I get LKJ. Your middle letter or your vertex can never move. And now, when they ask you to classifying here, they're asking you to say, is it right, acute, obtuse, or a straight angle? Okay, well, this looks bigger than a quarter, but not as big as a line, so this is an obtuse angle. Okay, looking here at number 2. Take a second, try to think what you think the answers are, and then let's go through this together. Okay, now that you've had time to try this, let's see what we get. So, name the vertex. The point in the middle is S. I make sure it's a capital S to show the vertex. The sides are, this is my vertex. Remember, it is also the end point for both of the sides, or in this case, both of the rays. So starting at that end point, I have ST. I also have SR. Okay, 3 ways to name the angle. Naming it with a vertex, it's angle S. Another way, start with an angle or a point on one of the sides, which is T. Go to the vertex, go to the other side, so TSR. Or I have angle RST. Notice S, my vertex, is always in the center when naming it with 3 points. Last question here is to classify. Notice I have the box in the middle. That box represents 90 degrees always. So this is a right angle. Anytime you see the box from here on out, always put 90 degrees there so you remember what that box represents. Okay, let's go back here to some more vocabulary. Okay, some of these probably look familiar because we went over the same type of vocabulary with segments. We're now putting them with rays and angles. So first off, what are congruent angles? These are angles with the same measurement, which when we talk about measurement of angles, it is really angles with the same degrees. Now, there are 3 ways that we can show that angles are congruent. One way is to have it written angle ABC is congruent to angle DEF. That's one way to show that angles are congruent. They have it written out with the congruent symbol in between. Another way to show it is if I draw 2 angles, A, B, C, then I have D, E, and F. They can simply be congruent by having the same degrees inside. So I could say that this is 40 degrees and 40 degrees. Those are congruent angles because they both have the same degree measurement of 40. The last way you will see congruent angles marked is with arc markings. Remember when we were talking about segments? So a little side note. When we were talking about segments, we said segments were congruent if they had the same tick marks on it. So since both those have a tick mark of 1, they are the same. They have the same distance, the same measure. Now, we don't put tick marks on angles. What we end up putting is arcs inside of the angles. So if your angles have the same number of arcs, those are considered congruent. Okay, getting here to the next one, what is an angle bisector? Okay, an angle bisector is a ray that cuts a big angle into 2 smaller ones at the vertex. The 2 smaller angles are congruent. So this is a ray that's going to cut a big angle into 2 smaller angles where those 2 smaller angles are congruent or have the same degree measurement. Okay, so if we look at what this is meaning. Okay, we're going to have a big angle here, A, B, C. What's going to happen is there is going to be a ray come in here, let's say at BD. And this, first off, this ray that cut inside of the angle that I just highlighted, this is the angle bisector. My angle bisector is BD. That is the angle that cut it into 2 pieces. What we are going to see is that on either side of the angle, they have the same degree marking, or one way we can denote also angle bisectors is on either side of that angle bisector, they have the congruent marking. representing that not do I have to see that the degrees are the same. I know they are the same by that marking. Okay, this one is a little bit tougher to see than a segment bisector. We will talk a little bit more about this here in class. Okay, going here, what are perpendicular lines? These are lines that cross and form 90-degree angles. So I'm going to have two lines. They're really going opposite. So if one is going up and down, the other one's going to go side to side. Where they touch, they form that box, or they form 90-degree angles. That's how I know I'm looking at perpendicular lines, is where they cross, I should be seeing 90 degrees. Okay, now a perpendicular bisector. This is a line that crosses at the midpoint and forms a 90-degree angle. So when I'm looking at a perpendicular bisector, okay, I'm going to have a segment here. I'm going to have a point that I know it's the midpoint. Remember, on either side of the midpoint, we have tick marks to show that on either side of the midpoint, pieces of information are the same. What's going to happen is either there's going to be a ray or a line or something that it crosses it at the midpoint, and it also goes through and it creates that 90-degree angle marking as well. Okay, these two with 90 degrees, we see a little bit more here later on. Okay, this is more the perpendicular lines and the bisector, more of a brief introduction so that you get to see that terminology. But like I said, we'll see it here again later. Okay, now, this example right here, this is a great example that there's going to be more than one correct answer for some of these. If you do not see that your answer is one of the ones that I talk about, okay, do not assume that it is wrong. Simply message me, ask if you are correct. I will tell you yes or no. This problem, there are more than one correct answer for some of these. Okay, going through this. What is the vertex of angle 1? So I'm going to take my pencil here. Here is my angle 1. It is inside of this top angle up there. I scratched over it with a pencil. The middle point of that is at T. That makes T my vertex. Why I did that in pencil is I can come through and I can erase so that I can deal with the same picture for all of these. Another way of naming angle 2. Here is angle 2. Okay, it is inside of angle X, T, U, or you can name the angle UTX. T is my vertex. Okay, here is what 2 is in the middle of. XTU, UTX. When naming an angle with 3 points, the middle or the vertex always has to go in the center. Okay, I can erase because we're going to a new problem again. Name the sides of angle 4. So here is 4. And I outline the angle with, again, pencil. Starting at the vertex is T. One of the directions go to Z, so TZ. And then I have T, the other one goes in the direction of WTW. Okay, now, the last ones want us just to name examples of some of the terminology we just went over. Name a right angle. Okay, right here I'm looking at this box. I can name it multiple ways. I'm going to name it angle 5. That is the number that is in between there. I can use it to name it that way. Could I name it other ways? Yes. Again, here's a reminder. If you name it a different way and you want to check if it's correct, message me. Ask it even at the question at the end. I will make sure to go over it in class. Okay, name an acute angle. I'm going to say angle 2 isn't acute. It is a small angle. Name an obtuse angle. Now, this is a great example that for it to be obtuse, we got to combine angles. So I'm going to say angle YTU. Okay, if I go over this, YTU. It's this combination of 1 and 2 together. That definitely looks like it is an obtuse angle. Okay, looking here at the next one, name a straight angle. This is naming a straight line with 3 letters. So YTZ. That's what's a Y in front. Angle YTZ. Let me rewrite that so it's easier to see. Angle YTZ. Is there other options? Absolutely. That's just one example I choose. Name congruent angles. These angles with these arcs here at angle 2 and angle 3 are congruent because they have those arcs. And now, name an angle bisector. The angle bisector in this case is going to be the ray that is in between the congruent angles. So this is TU. Okay, this example right here at number 3 is probably the most difficult. Whatever questions you have, please ask. This is as hard as the pictures and the problems get for naming and dealing with angles. Okay, now, angle addition postulate. This should look familiar because we talked about the segment addition postulate. It is almost the same thing. The angle addition postulate is the same formula. It is part plus part equals whole. Okay, we use the angle addition postulate to either find the big angle that is missing or one of the smaller angles. So if I look at an example, what we're going to see is pictures like this. This actually looks pretty similar to the picture we're going to see on that first example. My parts are these little small angles. My whole is this whole big angle that is just highlighted there on the outside. If I fill it in with this is like angle ABD is a part plus angle DBC equals angle ABC. Part plus part equals whole. Little plus little equals big. Okay, it's really not much different than segment addition, other we're looking at angles. So now, if I use my pencil to mark what I have, first thing, mark your picture. ABD, A to B to D, that's inside here, is 44. How I knew it was inside is I'm tracing A to B to D, and I go and I mark an arc inside of that. That is the 44. Then I have D to B to C is 62. I need to figure out ABC, which is the whole big angle. So 44 plus 62, those are my two parts, equals angle ABC, which is the whole thing. Okay? 106 equals angle ABC. All I did was I combined 44 plus 62 equals ABC. ABC equals 106. Okay, so now I'm going to erase my picture. So I am ABC, which is the whole thing. I'm going to write whole underneath of it, equals ABD, which is one of the parts, and DBC is another part. Part plus part equals whole. One of the parts is 53, plus the other part is angle DBC, and it equals the whole thing, which is 127. To solve for DBC, subtract 53 on both sides. I get angle DBC equals 74. There would be then my final answer for A and B. Okay, let's look at some more of these angle addition postulates. Okay, looking here at the next example. Okay, P, Q, R, which I'm tracing that hole outside. So this is a hole. I need to find the values of X, P, Q, S, and S, Q, R. So first off, these smaller pieces that are already marked in my picture are my parts. Part plus part equals whole. So part of 13x plus 4 plus the other part of 10x minus 1 equals the whole thing of 141. First thing I'm going to do is I'm going to combine like terms here on my left-hand side. 13x and a 10x becomes 23x. A 4 and a negative 1 becomes a positive 3 equals 141. Then I'm going to subtract 3 on both sides, and I get an answer of 138. Divide by 23, x equals 6. Okay, I found x. The other PQS and SQR is when I substitute in here. So for PQS, that'd be 13 times 6 plus 4. 13 times 6 plus 4 gives me an answer of 82. SQR would be 10 times 4 minus 1, or 10 times 6 minus 1. That'd be 60 minus 1, which is 59. There would be my pieces of information. X is 6. PQS is 82. SQR is 59. Okay, let's look here at another problem. DEF. Okay, that's on this whole outside thing, so this is a hole. Okay, DEG, that's this little piece right here, is 5x plus 1. And then GEF is 23, that's the other piece. They want us to find some different things. First off, we know GEF. GEF is 23, so I don't need to do anything with it. Okay, so now part plus part equals whole. Here's my parts, here's my whole. 5x plus 1 plus 23, part plus part equals whole. 7x plus 4. First off, on my left-hand side, combine a 1 and a 23 to be 5x plus 24 equals 7x plus 4. Subtract 5x. I get 24 equals 2x plus 4. Subtract 4. I get 20 equals 2x. Divide by 2. I get x to equal 10. Okay, I found x. Now I need to substitute in DEF. This is the 7x plus 4. Angle DEF would be 7 times 10 plus 4. That's 74. Angle DEG is 5 times 10 plus 1, and that's 51. Okay, and there is my pieces of information. I have x and all the angles. Okay, now looking here at the last one. DEF, which is this whole big angle. They tell me it's a straight angle. Straight angles means an angle is 180 degrees. DEG is 23x minus 3. GEF is 12x plus 8. They want me to find x and the whole angles. Well, first off, we know DEF is 180 because it's a straight angle, which is 180 degrees. Now, again, part plus part equals whole. You have a whole big angle split into multiple pieces. You always want to use angle addition postulate. 23x minus 3 plus 12x plus 8 equals 180, since that's the whole big angle. 23x and 12x is 35x. Negative 3 and a positive 8 is positive 5 equals 180. I get 35x equals 175. When I take 175 divided by 35, I get x to equal 5. All that I now need to do is substitute in 23 times 5 minus 3. 23 times 5 is 115, minus 3 is 112. And then I would have 12 times 3 plus 8. So that would be 36 plus 8, which is 60 plus 8, which would be 68. Not 3. It'd be 12 times our x was 5. My bad, my mistake. So 12 times 5 is 60, plus 8 makes it 68. So I have 68 at 112, and we know that DEF is 180. Okay, we are going to take some time. We're going to cover angles in class to make sure that we are familiar here with these angles. Any questions that you have from this lesson, ask them now so they can get added into the lesson beforehand. If not, I hope everyone is having a great day. Enjoy the rest of your day. And if you need help, please reach out to me. See you later. Bye, Honors Geometry.